CogSketch is an open domain sketch understanding system. Everything you draw in CogSketch is a glyph. To draw a glyph, you click the glyph button, draw, and click again to finish. When we use sketches to communicate, we rely on language to label the things that we are drawing rather than relying on other people to automatically recognize what we have drawn. We do the same thing in CogSketch with conceptual labels taken from the OpenPsych knowledge base. Each glyph can also be given a name. We do this to create a person named Bob and a dog named Fido. We can also draw relations between the objects in our sketch. We draw a relation using the relation button and draw all relations as arrows. Relations can also be assigned a concept from the knowledge base, and CogSketch will fill in the role relations for us. We can also use annotations to indicate important attributes of other glyphs in the sketch. To say something about Bob, we click on Bob, click the annotate button, draw the annotation, and then we can tell CogSketch that this is a length annotation meant to indicate how tall Bob is and that the value of the annotation is 6 feet.
Understanding a sketch often requires understanding the shapes of the objects in the sketch and how they relate to each other. The perceptual sketchpad is an extension to CogSketch that can automatically build up a representation of a glyph's shape. Suppose, for example, that we sketch out a T-shape. Here we draw another T-shape at a 90-degree rotation. While these glyphs look different, a person could obviously tell that they are actually the same shape. CogSketch will now decompose these glyphs into their component edges. Now CogSketch can compare its representation of the two shapes using the structure mapping engine, our model of analogical comparison. As the color coding shows, it is able to identify the corresponding edges in the two glyphs. Now we will compare sketches containing multiple glyphs. Before running the full sketch comparison, CogSketch will compare the individual glyph shapes. Shape information from these comparisons is included in the representations being compared. Therefore, when it compares the two sketches, it is able to identify the corresponding glyphs. Shape information is combined with spatial information in the sketch comparisons. If we change around the spatial locations of the glyphs, we can cause the spatial information to override the shape information in the comparison. In this case, each glyph matches to the glyph in the corresponding location.
Electronic worksheets are an educational application that we are exploring in CogSketch. Here's an example of a worksheet designed for a geoscience class. As the problem statement says, the student should draw a sketch over the background image that identifies the main fault, hanging wall, and foot wall. As the student draws glyphs, they should also tell CogSketch what those glyphs represent. In our papers, we call this conceptual labeling. After labeling all the glyphs, the student can get advice from the CogSketch tutor. The tutor uses the structure mapping model of analogy to compare the solution sketch and the student sketch. Differences between the sketches that are important, such as the location of the hanging wall and the foot wall, are used to generate suggestions. The student can modify the sketch based on these suggestions and hit the tutoring button again. This time, everything is right.
We are working with Northwestern's Engineering, Design, and Communication course to improve students' ability to communicate using sketches. Our idea is to create a design buddy for students to use in practicing explanations via sketching. One key problem in this task is to understand sketched mechanisms like this shock absorber. Existing QM models describe interactions between rigid objects. We use conceptual labeling to tell CogSketch which objects are rigid, as well as to indicate which are fixed in the frame of reference. We have extended our QM to include a class of non-rigid object, springs. As you can see from the labels, this is a compressed spring. With Digital Ink, there is no need to completely redraw the objects. Going back to the meta layer, we then use a relation arrow to tell CogSketch how these two situations are related. We'll say subsketch 1 causes subsketch 2. On demand, CogSketch looks at the state in the sketch and compares that with the QM prediction of what will happen. This time, everything matched up. If we change the sketch so the system behaves in an implausible manner, CogSketch will note the conflict. This work will form the basis of our design buddy.